Trains in the US today run slower than they did almost 100 years ago. In 1949, you could take the Montreal Limited train from New York to Montreal and get there in 9 hours and 5 minutes. Today, the same trip takes almost 2 hours longer. In a world where plenty of other countries have expensive, efficient rail networks, the same world where people are starting to talk about commercial space travel, why has American train travel progressed so little? And is there anything anyone can do to fix it? Two big issues might be to blame for America's railroad woes: freight train traffic and poor logistical planning. And there are technological solutions that, in theory, can address these pressing train problems. Smart sensors could be installed across the rail network to help enhance safety and operations. Advanced inspection technologies can also help reduce the need for track inspectors to halt or slow down train traffic. Dispatching software like air traffic control systems could take real-time data to optimize train movement across the network. If someone were to implement them, these solutions could significantly improve train travel in the United States. But the most ambitious solution would require a huge overhaul of America's train infrastructure, which, as we mentioned, lags dramatically behind that of its peers.
It's a big country, this land of ours.
Before we talk about new ways to address the US train problem, let's talk about what we're working with. Countries across Europe and Asia have already adopted high-speed rail, sometimes called the bullet train. These systems, mostly powered by electricity, move passengers at speeds of 124 miles per hour or faster. China alone has over 15,000 miles of high-speed lines and serves more than 1.7 billion passengers each year as of 2019. But high-speed rail in the US only covers a small chunk of the map. The longest train line currently goes from Boston to DC. Most of the rail networks in the United States are dedicated to freight trains moving goods and products across the continent, not passengers. In fact, the US has one of the largest freight train networks in the world, spanning 140,000 route miles, and it's owned and maintained by private organizations. Amtrak, one of the few publicly owned passenger railroads in the United States, operates only 300 trains a day, and about 70% of them run on lines owned by other railroads. According to Amtrak, freight railroads are required by law to prioritize passenger trains, but the law is difficult to enforce and often ignored. As a result, Amtrak trains must regularly slow down and yield to passing freight trains, which contributes significantly to its travel delays. And get this, on average, Amtrak's high-speed line runs at an average speed of only 66 miles per hour, much slower than its top speed potential of 150 miles per hour. So can we even call it a high-speed rail? If the US were to construct a completely independent high-speed rail network, advocates say it would not only improve Amtrak's service, it could reduce dependence on oil, decrease overall greenhouse gas emissions, help alleviate congestion, and stimulate intercity economic activity. But establishing train infrastructure has never been an easy task. The creation of the Transcontinental Railroad is considered one of the greatest feats of engineering of the 19th century. As the US expanded westward, trains became fundamental to the American transportation system and a primary means of connecting the growing territory. But in the mid-20th century, America's appetite shifted away from trains to the automobile. The federal government began to subsidize the interstate highway system with deregulation and federal funding. As a result, railroads were sidelined, unable to compete without money from the government. It wasn't until the 1970s that the federal government began investing in trains again with the creation of Amtrak.
Fly on a train.
All aboard, Amtrak.
But only a decade later, federal funding for Amtrak and the transportation sector at large was reduced. Some train routes were discontinued as a result. Amtrak had to rely on private rail companies for their pre-existing tracks. So, countries like the US have a long way to go if they want to upgrade to a more advanced high-speed rail system. From labor to specialized material, the economic costs to build a new high-speed rail network are vast and can span years. According to the World Bank, China's high-speed rail has an infrastructure unit cost of about 1.5 to 13 million US dollars per mile. And Europe's cost is about 15.5 to 25 million per mile, which means someone must pay for it in the US. High-speed railroad infrastructure also requires specialized design, construction, and maintenance. New dedicated lines have to be constructed along with new stations and systems of communication. An updated safety monitoring system is also crucial. In addition to funding, there also needs to be a lot of political will and cooperation to make high-speed rail a reality. To plan and implement a high-speed railroad project successfully, coordination across states and the federal government is required, along with bipartisan support, often challenged in a country politically divided like the US. So where do we go from here? In the absence of the necessary political support for high-speed rail, there are important smaller steps private companies and local governments can take to dramatically improve the US railroad system. One is ATI, or Automated Track Inspections. This technology inspects and measures track performance across the network using lasers and cameras mounted onto rail cars. ATI systems reduce track-caused derailments and increase track inspection efficiency, both of which would help alleviate train delays. Another technology, Broken Rail Detection, or BRD, uses sensors and GPS to identify any break in a rail track with great precision. This tool could make things way more efficient. Rails could be fixed faster, and trains would be rerouted earlier. And for better logistics planning, dispatching software can analyze train schedules, speed restrictions, and crew schedules to help train dispatchers determine the best operating plan for their portion of the rail system and respond in near real time to changing conditions, delays, weather, and unplanned maintenance work. These are all meaningful measures to improve the current rail system. Some individual states, including California and Florida, have decided to step up and lead the way in train travel innovation by building their own high-speed rail networks. When completed, these trains will transport passengers between major metropolitan areas in a matter of hours. And it gives transportation advocates hope that maybe one day you can hop a train from New York to Montreal in only 5 hours, not 11. Does your country have a high-speed rail network? Do you want one? Let us know in the comments.